Okay. So what's the next point?
It's 0, 1.
0, 1. Beautiful. Now that's a little weird, but the first piece tells me how much I move left and right. So how much am I going to move left or right? I'm not going to move at all. And then I'm going to go up 1. So I start here, I don't go anywhere, and I go up 1. That's the point 0, 1.
So if it was 0, negative 1, because
You would just go
X and a Y, so it would go 0 and down.
down 1. I love it. Yes, sir.
But how do you do the 2 plus 5?
What's that 2, 5 tell you to do? The first piece always tells you how much to move left and right. Starting at the middle. So how much do I move? I move 2. Positive. Positive 2. And then I move how much up?
5
up. That's how I got there. Do you see that? So you need both pieces to locate that point. The 2 piece and the 5 piece. That's why I don't add those together. I need them separate so I can see how to get there. Good, good, good.
Now with your X and your Y, your 0 always starts. That 0 is always considered your
0
X.
is always right in the middle of both axes. It's right where the 2 axes cross.
Well, I understand that, but I mean as far as it can always be your X, or... Yeah, your X. It's always going to be the axis, the 0.
No, no, no.
Because like...
The 0, 0 is right there. Right? This is the 0, 0. It's right where the Y and the X cross. So I haven't moved up or down or left and right yet. Right in the middle. So how do I get to the last one? 1, 3. How do I get here?
You go 1 to the right,
Yeah, 1 over,
up 3.
up 3. So that's point 1, 3. Now you guys tell me, does that look like it's a straight line? If I connect them?
Yeah.
Yes, right? Especially would be good if I could make a straight line, but we're just going to deal with it. Now real quick, I want to notice something. I only got 3 points. Guys, how many total answers are there? So one answer is 2, 5. Another answer is 0, 1. Another answer is 1, 3. But how many total answers are there to this? Too many? An infinite number. For every X you can imagine, every number you can think of, you can double it and add 1, and that's the other number. So you can do that forever. So thank God that we only have to do like 3 points, and the minute I connect them with the line, now look, what other point does this line go through? What point is this?
Negative 1.
Negative 1? Negative 1, I love it. Stay with me. We did not get that point from our work, did we? We got that point when we graphed it. But the fact that that point is on the line, what does it mean about that X value and that Y value? What must they do?
Be a negative 1.
What do they have to do here? When I put a negative 1 in for X, I better get a negative 1 out for Y. Isn't this the X piece and the Y piece?
Yeah.
What did this point really mean? What does that point mean? When I put a 1 in for X,
You get
I get a 3 out for Y, right? That's what the point 1, 3 means. When I put a 1 in, I get a 3 out. When I put a 2 in, I get a 5 out. So those are the points that I actually calculated. I put a 2 in, and I got a 5 out. This point's a little freaky. I got him just because I filled in the line. But any point that this line goes through has to work here. That's the connection.
So if you plug it in, does it look how it would?
Let's see. If it doesn't, I can just wrap up and all go home and never come back. So, y equals 2x plus 1. So if I let x equal to negative 1, what's twice negative 1 plus 1?
negative 2 plus 1.
Negative 2 plus 1,
Negative 1.
negative 1.
No, I'm saying do negative 1 equals negative 1x plus 1. You're like plugging in the variables with those two numbers.
We just did. If I let x equal negative 1, which means where am I going to put that? If x is negative 1, I'm going to replace x with it, right? That's what we did. If I put a negative 1 in for x, what should come out for y? Negative 1, because that's what the point says. When x is negative 1, what must y be? Negative 1.
That's crazy.
One reason why it's kind of cool that it looks freaky but at the same time, it's not that freaky. What is this? Do you notice a pattern? Every time I go up 2, how far do I go over? 1. If I go up 2, I went over 1. You guys see that? That pattern's got to stay. Or else it's going to curve. If that pattern ever changed, it would curve. It wouldn't be a straight line anymore, would it? So if I start here and I go, how do I go? Where must this point be if I can go up 2 and over 1? So it must be back down 2 and back 1. That's exactly how I get there. I got to follow that same pattern. Yes, sir. So the fact that it comes out to be a straight line is not too surprising when you realize, what does this say? Y must be this related to x. Y must do this for every x value. So they're lockstep. When I change x, y is going to change by twice that plus 1. So that's why it's not surprising that it comes out to be this straight line, because x changes by 1, y is going to change by 2. Twice that. Yes, sir?
I don't get it.
It's okay. We're just getting into this. We don't have to get everything yet. Yes, sir?
So that 2, when you see the y equals, because the y is your vertical, the 2x on your problem there, can you associate the 2x with your axis?
No. You gotta be careful. This is the relationship between x and y. These are the actual plug it in, get something out. Plug it in, get something out. Let's try another one.
How did you know what to pick though for?
It doesn't matter. I'm not going to pick 80 just because I want to stay like 1 through 5 here. You know, I want to stay in here. So I'm not going to pick an x of 80 because I would have to go way the hell out there. You kind of with me? So normally when I have to plug stuff in, I do like -1, 0, and 1 at least. So let's try another one. And then I got a little handout so I can finally shut up and let you guys try something. What's that?
Karen already there, it's on your desk.
They gave me a fake test.
What's that?
I don't know, I used their quiz and then they turned it into real.
That is funny.
Should have been on time, right?
It's Math 125.
Read it either.
It's awesome.
The first
Did I
test
get it
was you
right?
didn't read the heading.
Did I get it right?
I don't know. I can't check it right now. Let's try this. Yes, sir. We're going to do this one together. What's the matter?
Don't get it.
You don't have to get it immediately. Alright? You're just learning this. That over there. Myself over. Alright, guys.
Alright, what's that?
I'll tell you what. Let me take a step back. Alright, you guys look at this equation here. This is a little, not in the same format, but this is not a bad one to just think about in general. Can somebody give me, now, an answer to this equation requires 2 parts, because, why does it require 2 parts?
Because there's x and a y.
Because there's an x and a y. I got to know both values, right? So if you tell me the answer to this is 7, like what the hell's that? There's 2 questions in this, isn't there? Just like there's 2 questions in that one. It's just a little bit, it's just been moved around a little bit. You with me? Now this one's a little bit easier to think about directly. I just need 2 numbers that do what?
3 plus 3.
So give me one answer.
3 plus 3.
3, I love it.
4, 2.
Or 2, 4.
2, 4. 4, 2. Now,
1, 5.
1, 5. What about 7?
Yeah.
Subtract 1.
2. So the minute you set one value, the other value has to be a specific thing. It's got to make 6. So the first number I can make either one of them. I can make that 10.
-4.
-4. I love it. So the minute you set either variable, the minute you give it a value, the other variable must be a certain thing to make it true. So I can let x, or y really, but I can let x be any damn thing I want it to be, but then y has got to be the specific value that makes it true. guys got it with me?
Yep.
They have to go together. That's why I said at the very beginning, they're an ordered pair. This value goes with this value. So if I let x in this expression, I give myself a little room so I can work this out. So this is my first point. If I let x be negative 1,
Negative
so I'm
5.
going to throw it, oops, you know, what happens. So is that cool? That this is the equation I'm working with. If I let x be negative 1, that's what I've got so far. Is that cool?
Yeah.
Because that's just plugging that value in for x. Right, just throwing a negative 1 in.
Can I say one twice?
Oh, yeah, sure.
Negative 5?
So this is the first point. Y equals negative 3 minus 2. Y equals negative 5. So then that value you're going to put right there. So negative 1 must go with negative 5. There's no other answer I can get, is there?
No.
We just got negative 5. That's the only answer. When I make x negative 1, it can only be negative 5. So what if x is 0?
Negative 2.
Y equals 3 times 0 minus 2. Y equals negative 2. I like it. So that's going to be right there where the y value is. Okay, good. So this one was really easy to think about. I didn't need to do all that work because I could just think of two numbers that make 6. Not a big deal. But when it's a little more complicated, I have to assign one of them a value and then figure out what the other value is. All right, so if we do one more, if I make it 1,
You get 3.
y equals 3 times 1.
Negative 2.
3 times 1 is 3. Y equals 3 minus 2.
1.
Y equals 1. Good, so it goes through 1, 1. So if I had a rocket that was following this path, once I draw the equation on the graph, I can see where the rocket would go. Right? The rocket takes off and it goes at something, and then later, next semester, you guys would have something coming in here and you want to hit it.
Oh, what the hell?
Right? You have a Patriot missile and a Scud missile, and you want that thing to hit it, or else, the people down here are like, oh, we missed Ocean. So you want a good mathematician down here, and of course the computer does it all, but to actually make them meet, to actually make them hit each other. Yes, sir?
Why?
Why, what?
Why do I hit each other?
In this case, I'm talking about somebody shot a missile at you. You're going to want to blow it up so that you don't die.
Or run.
And so these really relate to one equation graph and the other equation graph, and you want them to hit. You guys kind of with me?
And objective.
At the same time. I like it. I'm trying to give you a physical, real-life reason why these equations are important and why we want to graph them. So something I kind of skipped over. How long could this list be? Infinitely long. So if I told you, give me all the answers to this, I didn't say give it to me as a list. You could graph this, give it to me, and say there.
But it will keep going, right?
Exactly. You just put a little arrow.
Yeah.
Right? So you get these points, you graph them and you connect them. So what we're really doing when we graph a graph is we are giving this the quickest way to answer what are all the answers to this. There's an infinite number of answers to this. So what's the quickest way to answer? What's the answer is to give somebody a graph, and then they can go find their own specific answer. So how do I graph the points we got? -1, -5.
You go to the right, to the left.
Good.
And down.
All right, you go down 5. 1, 2, 3, 4, 5, and
1.
back 1. So that's the first point. What about 0, -2?
0 down 2.
Yeah, I don't move left or right at all, right?
Nope.
0 says don't go anywhere.
Down.
Down 2. So that's the second point. And then 1, 1. Can't go wrong there. One over? Careful.
Oh, no. Oh, yeah.
They're both positive, right? So notice positive is right and up. Negative is left and down. It's kind of nice because if I'm in a car, I can go positive forward or negative backwards. So the idea of negatives and positive meaning direction makes total sense. Hopefully. So now I can connect these. And this is the day I wish I would have brought my... Yeah, exactly. So now if somebody wants another answer, they can just kind of go somewhere else and get their answer for themselves. I don't want to have an infinite list of numbers. I don't have that kind of time. So I'm just going to do a visual. This is a visual representation of all the answers to this equation. That's what a graph is. So that's one level of why we graph. The more important level of why we graph is when we get the picture of it, we can see things that we might not otherwise see. And then if I had another equation coming in, I can see, are they going to actually hit? Like I was saying before. Right? I want to take that thing out. How are we doing? Okay, maybe. All right. So let me do this. Let me go ahead and get to the point. All right, you shut the hell up. You guys try this out. You work together or alone. It's not a quiz.
No.
One here.
Oh, you're.
Oh, you I couldn't even math. Yeah, that was bad. What is it? That baby? Yeah, I know. Our group gets a class per time, right?
That's true.
One in our study group. Yeah, you're right. So you want to give another save? Give another chance.
You didn't